In the general meeting update, I was getting some things organized on my tractor in order to do more field testing, and what you're seeing on the screen is a HTML file that maps the lat long position of an actually running field test. It's maybe 500 feet, 150 meters out and around an obstacle just to test, and then back up. And what it's showing is the fix quality. Green is good, yellow is tolerable, and anything else is questionable. Green meaning RTK Fix. This first bit of yellow is heavy foliage under a tree. Not quite sure what caused it to drop here for brief moments. Need to do more analysis on that data. So all in all, I was really pleased with how everything worked. What is not intuitive on this is my base station was sitting up here in the back of my pickup truck, and there was a router in there that was obviously an omnidirectional router that was projecting signal across this 2 or 3 acre plot. So all in all, I was pretty happy. Speaking of the router, I have this plot as well, which was showing my Wi-Fi signal at various times. You can see the legend down here, and although I was able to maintain RTK Fix and the correction data was coming in, the Wi-Fi signal was getting a little dodgy, which is one of the findings from my test. Is it was about to rain, and I needed to protect my equipment because it's not completely weatherproof. So a more permanent solution will be to put the base station over here and project the signal over this way, or I guess ideally in the center, and come out, but that's not really conducive to sort of the physical characteristics of the plot. So the other thing that was sort of interesting to me is this shows I have actually 2 network connections on my tractor. One going back to a video that we made last week. There is a router, a small travel router on the device, which captures the SSID from the base station router. So you're getting router to router communication, and you're also getting a Wi-Fi signal that's being picked up by the Raspberry Pi, which is down here. And one of the surprising pieces of data, for me anyway, was this plot shows at which time, when it says GL router, that's the white router box. When it says RPI WLAN, that's the Broadcom chip on the Raspberry Pi. So it was interesting to me that sometimes the Raspberry Pi is actually getting 3 dB stronger signal than the white router. I was really blown away by that. So although I'm not going to rush out and rip the white router off, it is interesting to know that the signal on the Broadcom Wi-Fi chip is able to pick up materially noticeably stronger signals even when it's in a slightly depraved area. So let's see, we maintained RTK Fix for a large share of the time. As I mentioned, I was surprised by the Wi-Fi chip performance. I've got some additional analysis scripts now to be able to compare Wi-Fi comparison and RTK status, which is good. Some things I need to work on I need, as I said, move the network router so the signal strength, I'm going to shoot for, say, um, greater than -75, which is basically a strong signal. I was also trying to track speed data, and although I have an analysis tool to use the lat lon data to calculate speed, I'm supposed to be getting speed through one of the NMEA sentences, and that wasn't flowing through, so I've got to go back and look at either my parsing or do I have the right NMEA sentences coming through to capture speed data. And then additional data elements to debug the loss of RTK. What I'm particularly interested in is when I lost RTK here, went from fixed to DGPS, sort of what was going on. You can see the Wi-Fi signal was strong at 62 and -62 and -58 on the respective networks. So it's not correction data being able to get to it, but something triggered that loss, and I didn't capture good data in order to debug that a little bit further. So anyway, all in all, a really fantastic run, and I'll get back out there hopefully soon when the weather's a little bit better and capture some more data. Have a great day.